Hello everyone, this is Mr. O, and I'll explain you everything about negative and fractional exponents. If you trust me and follow me until the end of the video, you will learn a lot about exponents. Okay? I'd like to first review the concept of exponents with you. You probably wouldn't know this already from grade 7 or grade 8, right? Let's look at the first example. What is 2 to the power of 3 times 2 to the power of 2? You know, these are called base numbers because they're down here when the exponents are upstairs. So that's why they're called base numbers, okay? And you know, if base numbers are same, we can simply add the exponents, right? So that's gonna be 2 to the power of 5, which is equal to 32. Okay, next. 2 to the power of 3 divided by 2 to the power of 3. When it's a division, what do? We subtract them, right? So 2 to the power of 3 minus 3. So that's going to be 2 to the power of 0. And you know what this is? Something to the power of 0 is always 1. Did you know that? Like for example, 7 to the power of 0 should also be 1. Any number to the power of 0 should always be 1, okay? Now the last one. 4 to the power of 3 times 3 to the power of 3 divided by 4 to the power of 2. So we have different base numbers, right? To make it look better, I'm just going to move 4 to the power of 2 to the front so I can put these two together. So this is going to be 4 to the power of 3 minus 2 times 3 to the power of 3. What can we do about this 3 to the power of 3? Nothing, because the base number is different, right? We cannot do anything about it. So in the end, this is going to be 4 times 3 to the power of 3 is 27, right? So 112. Alright, we're done reviewing. Now let's get back to our topic. We're going to first learn about negative exponents. I'll go straight to the point, okay? As you can see, this is the negative exponent. What is 2 to the power of negative 1? That should be 1 over 2. 100 to the power of negative 1 should be 1 over 100. Do you get the idea? What should x to the power of negative 1 be? Assuming x is just some number. Of course, it should just be 1 over x. So if the exponent is negative, you just have to flip the numbers. Then how about 1 over 10 to the power of negative 1? So 10 is already been flipped, you have to flip it once again. So that should equal to 10. Okay, now you could perhaps pause the video for a moment and try it by yourself. So assuming that you guys have tried it, 3 to the power of negative 1 should be 1 over 3. What about 1 to the negative 1? It's just 1, because 1 over 1 is just 1, right? A to the power of negative 1? Of course, 1 over a. How about this whole expression to the power of negative 1? It should be 1 over this whole expression, of course. So 1 over x plus 1, okay? Do you get the idea now? Now let's get into the actual problems. Again, you may pause the video for a moment and try everything by yourself. I'm going to assume that you guys have done it. Let's look at question 1. 2a to the power of negative 1. You should know this now. It should just be 1 over 2a, right? But how about question 2? You see there's a difference. This 2a to the power of negative 1 doesn't have a bracket. And you know what that means? If there's no bracket, that negative 1 is only applied to a. So this is actually 2 times a to the negative 1. So that is 2 times 1 over a. Yeah, I'm just going to use dots as a multiplication symbol, okay? And this will also mean 2 over a, right? So that is the difference, and you should be very aware of this, okay? If there's a negative 1 outside the bracket, that means that negative 1 is applied to everything inside the bracket. But here, we don't have the bracket, right? So it should only be applied to A. Now, question 3. We did this already too, right? 5 is being flipped, so we should just flip it back. Now, how about question 4? 0.01 to the power of negative 1. You know, whenever I study math, most of the time, I prefer to use fraction instead of decimals. So what I'm gonna do is, I'm gonna turn this into fraction first. So 0.01, that is 1 over 100. Am I right? And to the power of negative 1. We haven't applied that negative 1 exponent yet. So what is this? This should simply be 100. So this is why I prefer fractions over decimals. It's a lot easier to think about flipping numbers. Now, question 5. 2 over 3 to the power of negative 1. So you're flipping everything inside the bracket, right? So 2 should go down and 3 should go up. 3 over 2. You see? You just have to flip everything. So that means, what should this be? Square root of 2 to the power of negative 1. That should be 1 over square root of 2. Now, we have this long expression, question 7. X minus 3 to the power of negative 1. Because they're all in the bracket, we should flip them together. 1 over x minus 3. How about the last question? 0.5 to the negative 1. I hate decimals. Why don't we just convert this into fraction and then calculate it? Sounds good? So 0.5, what is that? That's a half, right? It's just 1 over 2 to the power of negative 1. Which means this should be 2. I hope negative exponents are more clear to you now. We're not done yet. We still have 2 more questions left. Alright, everything we have solved was something to the power of negative 1, right? Now, it's 3 to the power of negative 2. So, what is something to the power of negative 2? Let me show you this. 3 to the negative 2 should be same as 3 to the negative 1 times 2. How about that? It's correct, right? And we have multiplication in exponents, not addition, okay? Don't get confused. Multiplication means we could write it like this. So like, if this was negative 1 plus 2, that would have meant 3 to the negative 1 times 3 to the 2, right? But this is 3 to the negative 1 times 2, okay? This is a completely different story. This means it's 3 to the negative 1 and outside there's 2. Okay, don't confuse these two cases, alright? So, back to the question. 3 to the negative 1, let's calculate this first. That should be 1 over 3, right? We just have to flip them. Now that to the power of 2, what is this? It's like 1 to the power of 2 and 3 to the power of 2, right? We have to apply this 2 to both the denominator and numerator, right? But it shouldn't matter, like 1 to the 2 is just 1, right? And the denominator is what's changing. So that is 1 over 9. That is the answer. Alright. Finally, last question. 2 to the power of negative 3. So this means we have to flip it and then power it with 3. That should be 1 over 8, correct? That is the answer. So here I skipped this step, but you get it now, right? Congrats, you now know what negative exponents do. But did you know that exponents could also be fractions? This time, we're gonna learn about fractional exponents, okay? Let's think about this number, 2 to the power of 1 over 2. What could that mean? I'll ask you a question. What do you think is gonna happen if we do 2 to the power of 1 over 2 times 2 to the power of 1 over 2? The base numbers are the same, so what can we do? We can add the exponents, right? So 2 to the power of 1 over 2 plus 1 over 2. And what is 1 over 2 plus 1 over 2? That's just 1, right? And surprise, 2 to the power of 1. That is just 2, right? 2 to the power of 1 over 2, whatever that is, we just obtained this 2 by multiplying these two same numbers. What do you think this is? Shouldn't that be square root of 2? Yes, we just figured out what this number is by ourselves. 2 to the power of 1 over 2 is in fact the same number as square root of 2. These two are the same thing. Some mathematicians like writing it this way, and some others like writing it this way. That's all. So we can apply this concept to other numbers. What should 3 to the power of 1 over 2 be? Square root of 3. How about 4 to the power of 1 over 2? Square root of 4. And you know, square root of 4 is equal to 2, right? How about x to the power of 1 over 2? As long as x is some number, it should just be square root of x. I hope that was clear to you. Now we're back again to some actual questions. Let's look at question 1. 16 to the power of 1 over 2. 1 over 2 means just square root, right? So square root of 16. And you know what the number is? That is 4, right? So that was easy. Now, question 2. 36 to the power of 1 over 2. Again, square root of 36. And you also know what that number is. That is 6, right? How about question 3? 1 over 9 to the power of 1 over 2. So we have to square root everything, alright? Like this. This means square root of 1 over square root of 9, right? And what is square root of 1? Just 1. Square root of 9? 3. 1 over 3. Does that make sense? 1 over 9 to the power of 1 over 2 is 1 over 3. I think that makes sense. How about 10,000 to the power of 1 over 2? So a number that becomes 10,000 when it's squared, if you think in an opposite way. That's 100, right? Now, question 5. X to the power of 2 to the power of 1 over 2. So this is like square root of x to the power of 2, right? That should just be x, because we're canceling this 2 with the square root, right? Or also, you can think of it this way. X to the power of 2 and then bracket and 1 over 2, right? So this bracket means, we just discussed it before, right? It means multiplication, right? Between the exponents. So it should simply be canceling each other. And we're going to be left with x to the power of 1, which is the same thing. So you can think of this in two different ways. But anyway, we get the same answer. Now, question 6. Be careful here. 1 over 7 to the power of 1 over 2. What should that be? Just to warn you, I'll just give you a hint. Look at question 3. There's a difference between the two questions. We had a bracket for question 3, right? But here we don't have it, right? That means this 1 over 2 should only be applying to 1. So this is like 1 to the power of 1 over 2, like this, over 7. 7 is not affected. And what is 1 to the power of 1 over 2? That's just square root of 1 over 7. And that should just be 1 over 7. This operation was actually pointless, right? But yeah, that is the answer. Okay, question 7. 3 to the power of 6 to the power of 1 over 2. As I said, this bracket means multiplication, right? Like this. So that should be 3 to the power of 3, which is equal to 27. Okay, this is the last question. Question 8. A to the power of 4 times b to the power of 2 and everything to the power of 1 over 2. So because we have a bracket, everything should be square rooted, right? Like this. This means this, we can separate them, yeah. And that should be a to the power of 2, and this should just be cancelled, so it's just gonna be b. So the answer is a to the 2 times b. I hope that was a good practice for you. Now moving on. We have so far learned negative exponents and fractional exponents. But there's more about fractional exponents. I'm sorry, but if the exponents could be fractions, shouldn't this case also exist? 27 to the power of 1 over 3 is not 1 over 2, but 1 over 3 this time. And I actually taught you how we should figure this out. Do you want to try it on your own? You may pause the video for a moment and try. But for those who don't want to waste time, I'll start explaining now. You know what I'm going to do? This time, I'm going to try to multiply this number 3 times. Then what will happen? The base numbers are the same. So again, that means we can add all the exponents, right? Then what will happen to the exponent? It'll become 1. Which means the answer is 27. So again, we just multiplied that number 3 times to get 27. What should this number be? 3. In fact, 27 to the power of 1 over 3 is equal to 3. Take a moment to think about this. Let me ask you this now. What should be 4 to the power of 1 over 2? 2, right? Because 1 over 2 means square root, right? How about 27 to the power of 1 over 3? That was 3, right? Didn't you notice anything? 4 to the power of 1 over 2 should be 2, but then 27 to the power of 1 over 3 is 3. This is definitely not square root. Now, how about 2 to the power of 1 over 2? Obviously, this is square root of 2, right? Now, how about 3 to the power of 1 over 3? I know you're confused, I know. There's actually something you probably never knew. 3 to the power of 1 over 3 can be written as cube root of 3. What on earth is that? You've been only knowing the square root, right? But you've never heard of cube roots. Yes, it actually exists. Cube root means you have to multiply 3 times to get the number inside here. As if for the square root, you have to multiply 2 times to get the number 2. And you know what else? The most proper way to write the square root of 2, this one, is actually including 2 in front of the square root sign. But you know what happened? Everyone just got lazy to write it, so that's why we started just using square root sign without this 2 in the front. I'm not saying that you have to start putting this 2 in front of square root, but you should still remember, there should actually be 2 in the front, just like how we have 3 at the front, which means cube root, not square root, okay? I'm just letting you know the truth. It's always good to be aware of the truth. So you can just keep writing the square root without the 2 at the front, okay? Alright, let's move on. Alright, now let's try to solve some questions so you can remember all this. What is 8 to the power of 1 over 3? So that means a number that becomes 8 when you multiply it 3 times. And let me just write this down in terms of cube root. So what is that number? 2. If you multiply 2 3 times, it becomes 8, right? How about question 2? 64 to the power of 1 over 3. So a number that becomes 64 when it's multiplied 3 times. 4. Okay, I hope you're following me well. Now question 3, 1 to the power of 1 over 3. Obviously, that should be 1. It's the easiest question. Now how about 1 million to the power of 1 over 3? So a number that becomes 1 million when you multiply 3 times, do you know? Do you know that number? It's 100. Check it. If you multiply 100 3 times, it'll become 1 million. Alright, let's move on quickly. X to the power of 6 to the power of 1 over 3. As I said before, if there's a bracket in between the exponents, that just means multiplication, right? 6 times 1 over 3. And of course we can cancel these numbers like this. So that's gonna be x to the 2. And in fact, think about this. If you multiply x to the 2 3 times, it'll become x to the 6, right? So it all makes sense. Okay, question 6. 1 over 16 to the power of 1 over 4. So that should mean, so what should that mean? It should be a number that becomes 1 over 16 when you multiply it 4 times, right? 1 over 2. Okay, next. A to the 3 over b to the 3 to the power of 1 over 3. Because everything is inside the bracket, of course 1 over 3 should apply to both numerator and the denominator, right? So a over b. And if you think about it, if we multiply a over b 3 times, it should be a to the 3 over b to the 3, right? Alright, next question. Cube root of 125. So a number that becomes 125 when you multiply 3 times. You guys should be smart enough to know this. 5, right? If you multiply 5 3 times, it becomes 125. Alright, next page. Okay, we are almost at the end. Here are some challenging questions. We have to use all of our knowledge now. 8 to the power of minus 1 over 3. So there's a minus sign, so we have to first flip it, right? And then to the power of 1 over 3. And what is the number that becomes 1 over 8 when you multiply it 3 times? 1 over 2. So that is the answer. Now how about 64 to the power of negative 1 over 2? So again, negative sign means we have to flip it first. And then 1 over 2. And what is this? Don't get confused. This time it's 1 over 2, not 1 over 3, okay? So a number that becomes 64 when you multiply twice. 1 over 8. Okay, next. 100 to the power of negative 1 over 2. Again, 1 over 100 to the power of 1 over 2. 1 over 10, right? Because if you multiply 1 over 10 and 1 over 10, it becomes 1 over 100, right? Okay, next. A to the power of negative 1 over 2. 1 over a to the power of 1 over 2. Because we don't know what that number is, we're just going to keep it as square root of a. 1 over square root of a, okay? Oh yeah, I did apply 1 over 2 to the numerator as well, but it's just 1, right? So I skipped that. Alright, question 13. 4 over 5 to the power of negative 2. So there's a negative sign, so we have to flip them entirely. So 5 over 4 to the 2. That should be 25 over 16. Question 14, 15, and 16 are the questions that could be on the school test. You want to try it on your own first? If so, you can pause the video for a moment, but for those who want me to just explain it, I'll continue, okay? So 4 to the 3 over 2. That's something new. You know, we can rewrite this as 1 over 2 times 3. How about that? Do you agree? I mean, 1 over 2 times 3 is in fact 3 over 2, right? So there's nothing wrong with this. Now what I'm going to do is I'm going to apply 1 over 2 first. So that's going to be 2. And we have the rest 3 here. And that should be 8. And you know what? You could have applied 3 first. So that's going to be 64 to the 1 over 2. But you should still get the same thing, 8. So whichever you apply first, it doesn't matter. It's multiplication, so pretty convenient. Alright, 27 to the power of 2 over 3. Again, you could separate this as this. You know what? I'm going to apply 1 over 3 first. I think that's going to be more convenient because that's going to be 3 to the power of 2. So that should be 9. Okay, the hardest question left. And this is going to be our final question. What is cube root of 64 plus 0.25 to the power of negative 5 over 2? So let's do this one first. Cube root of 64, that should be 4, right? And 0.25, as I said, I really hate decimals. I'm gonna change this to a fraction. You know, 0.25 should be equal to 1 over 4, right? They're the same number. And that to the power of negative 5 over 2. Okay, so that means 4 plus... Okay, there's a negative sign. Let's flip it first. So it's gonna come back to 4. And we haven't applied 5 over 2 yet. Okay, I'm a little bit out of space. Okay, 4 plus 4 to the power of... I'm gonna apply 1 over 2, which is square root, first to 4. So that's gonna become... Okay, 2 to the power of 5. Make sense? And 2 to the power of 5 is, oh no, I'm going up all the way up. 4 plus 32, and that should equal to 36. Wow, I reached the top. Okay, so good job everyone. That was everything we needed to know. And good job on following me until the end. But wait, of course you need a homework. You should definitely try this homework to even strengthen your knowledge, okay? I hope this video helped you understand the exponents. And I'll show you the solutions in the next video, okay? So see you next time.